Okay, everyone, welcome to the Exhibitor track. I'm Jean Laval, a volunteer in the OWASP community, and I will be moderating this session. During the next 45 minutes, you will be listening to Ziad Ghalleb, who presents Show Source Code is revealing our secrets, how attackers find and use public credential to breach our apps. Please submit any question you have during the session in the Q&A tab just to the right of this video in the WUA platform. I will be asking Ziad your question in the last 10 minutes of this session. Please note that the chat function in Zoom is disabled for attendees, but you can leave comments and chat using the chat tab in WUA. Ziad is a product marketing manager at GitGuardian, a global cybersecurity startup based in Paris, France, so you will excuse my French accent as well. He has an engineering background. He is a security enthusiast and draws upon his experience as a solution engineer and consultant for engineering teams to advocate better developer experience in application security. Developers are always part of the solution, by the way. Ziad, the floor is yours. I'm turning off my camera.
Thank you, Jean-Denis. And thank you everyone for tuning in. I'm very happy to be here with you today. And I will be talking about how source code is revealing our secrets, a topic that is very dear to me. So let's get started. First, let's define what are secrets. Secrets in software development are digital authentication credentials used to authenticate different components against each other. So here we're talking about your front end communicating with your back end, talking to your database, your back end also talking to multiple services, APIs, etc. So these components need to authenticate against each other to secure the connection that they have between each other. Now, let's give some examples of secrets to illustrate this notion. Usually, secrets refer to API keys, username and password pairs, SSH keys, database URLs, JWT tokens, etc., etc. But we should also consider sensitive files such as .env files in your directories or certificates as secrets. And as you can see here in this example, we have a hard-coded AWS key, and of course this is a dummy key, so don't try pinging the AWS server, but we'll talk in this conference about how these keys should not be hard-coded in Git repositories and how they end up exposed. But before we get there, let's understand how the use of keys is today ubiquitous. So the way modern applications are built today is very different from what we used to do 2 decades or 1 decade ago. Developers are taking off-the-shelf components, they're taking third-party APIs, they're building microservices, and they're connecting all of these different components between each other to build the software. And to illustrate this, we have a real-life example from Uber's engineering environment here, where circa mid-2018, Uber tried to map its different microservices and components and found out that it had more than 2,200 critical microservices in its engineering ecosystem. So all of these different components talk to each other and authenticate against each other with the help of secrets. Now, sometimes the secrets will be in places where they shouldn't really be. And this is what we're going to address during the talk. So when the secrets end up exposed, they will be used by attackers for malicious use, of course. And one such example of an attack using exposed secrets is the famous supply chain attack that happened to CodeCov back in March 2021. So this breach was done by very sophisticated attackers who exploited a mistake in how CodeCov built its own Docker images. They used this to modify a script which allowed them to send environment variables from CI environments, so where CodeCov was used by its customers, to a remote server, the attacker's server. So the attackers could have conducted multiple attacks from there, and we can see based on some of the disclosures that they exploited many companies out there. the total number is put at 20,000 customers today. Now, this shows the importance of keeping Git repositories clean and Docker images clean from secrets and ensuring that production credentials do not end up in such areas. Another example is the recent source code leak from Twitch back in October 2021. So GitGuardian analyzed the Git repositories that leaked, and we're talking about 6,000 Git repositories and about 3 million documents. And we found more than 6,000 exposed secrets. Well, we don't know if all of these secrets were valid because we did not try and testing them for validity because we don't want to interfere with any investigation. But what we saw is that in these Git repositories, there were many interesting secrets that should really not be there and that could be leveraged by attackers very easily. So we found AWS keys, Twilio keys, GitHub OAuth keys, some Google Cloud keys, Stripe keys, and many, many others. You can read more on the GitGuardian blog on this source code leak. Now, what we did at GitGuardian is produce this annual research on the state of secret sprawl, which takes a look at the leakage of credential in public spaces. The first year in 2021, we looked at public GitHub. And now this year in 2022, we looked at public GitHub, Docker Hub, but also private Git repositories. And I will be sharing with you now some of the findings of this report. But before we get there, let's take a look at the methodology we followed this year. So how did we look for those secrets in public Git repositories and Docker Hub, Docker images? First, we have two different types of detectors. Specific detectors, which look for specific types of credentials. So these can be AWS keys, Stripe keys, basically anything that can be tied to a known service. And then there are generic detectors, which are perform high entropy checks to find generic secrets in code. These can be private keys, certificates, or anything that cannot be directly tied to an external service. And we also perform some sorts of validity checks, which are non-intrusive API calls to verify the validity of these secrets before considering them as a true positive or not. Now let's look at the where. So we scanned every public GitHub commit in 2021, every single public GitHub commit. That's more than 1 billion commits. On Docker Hub, however, we took a random sample of 10,000 images. Docker Hub has 8 million images, and we just took a sample here to see what the state of secret sprawl was like in Docker images. And lastly, we take a look at internal repositories. So these are the different VCSs used by users of GitGuardian internal monitoring. And of course, we did not share any sensitive data, but it's aggregate statistics and total numbers here. Now, let's take a look at the results. So the results were staggering, and this year was worse than the previous one. So it's not getting better for the secrets, really. GitGuardian detected in total over 6 million secrets on public GitHub repositories. And that's a twofold increase versus the previous year. Now, we're taking a look at the same perimeter because from one year to the next, of course, we add more and build more detectors. So looking at the same perimeter, it was a twofold increase. But looking at the new perimeter with the new detectors, it was actually a 3 times increase. Now, on average, every 1,000 commit, we found 3 commits that exposed at least one secret. And that's a 50% increase compared to the previous year. Now, the numbers are big, but let's also put things into perspective. GitHub is huge. It's the largest community of developers out there. So there are more than 60 million GitHub users, and there are more and more repositories created last year. And there are newcomers to the development world who do not necessarily know all the risks of poor secrets management and what could happen to them if they expose these secrets in public. So that also explains why we found so many secrets this year compared to the previous one. Now, the types of secrets we found were different. So there are many categories here we can see. And one interesting insight is that generic secrets, which are private keys, certificates, etc., they make up more than 40% of the total, whereas specific secrets make up the rest, so 60%. And if we look at that specific secrets category, we see that data storage ranks first. So these are database credentials we found. Cloud providers, so AWS, Google Cloud Keys, Alibaba Keys, those came in second. And lastly, developer tools used to build and test the software came in the third position. If we focus on cloud services providers, leaked keys, we can infer some interesting insights from the data we found. So here in this graph, we look at the number of detected secrets for these cloud providers in every 10,000 public GitHub commits. And as you can see from the chart, the AWS IAM keys are the majority of secrets we found for cloud providers. So for every 10,000 commits scanned, there are 84 AWS keys in public GitHub. And if we consider all other things being equal, this also shows us that AWS is dominating its market, and we can infer this. Now, we can also learn lots of other interesting insights from publicly exposed secrets. So here, for example, we found out that leaked secrets correlate to the popularity and growth in the adoption of certain new products and developer tools. So we released 2 detectors, which are for the Planet Scale database as a service provider, and Supabase, which is a backend as a service provider. And you can see the growth in the bars here, and which means that more developers are leaking the secrets from these services, and more developers are actually signing up and using these services. Now, it's not just the code where we found secrets, and I kid you not, this is really true, that we found commit messages themselves containing secrets, and most of the time these secrets were GitHub personal tokens. So in total, we found more than 500 commit messages containing these personal access tokens, and this is a very risky secret to expose, because then your GitHub account can be used to clone your repositories or to insert malicious pull requests, etc., etc. Now, some days when it comes to leaked secrets are clearly worse than others. So we found that leaks mostly happen on weekends. We can see here that Saturday and Sunday on average have a 2 to 4% increase compared to the average the rest of the week. And well, developers on Monday morning, maybe it's the coffee, I don't know, but it helps because they're leaking less secrets, at least from what we can see. And the worst day in 2021 was Saturday, November 20th, where we saw a 66% spread from the average in terms of secrets per commit. Now, if we take a look at the days across the year, and the worst days of the year, of course, excluding weekends here, we see that summer is a particularly good season for leaked secrets. So lots of secrets leak in August, July, and also March. And also, most of the countries are not equal when it comes to leaking secrets. So the top 3 countries we saw were, well, India, the USA, and Germany. Now, this does not mean that developers in these countries are better or worse at managing secrets than the others. But what it means that, because this is the total volume we saw for each country, this translates into the activity in software development and technology in general we see in these countries. So leading the charge is India, where lots of software development is happening in the world, the US, of course, and in Europe, Germany and France. But if we divide the number of secrets leaked here by the number of developers and then by the total population in these countries, we see a constant ratio of secrets leaked per developer. So in terms of practices, all developers are equal, I would say. Now, we also looked at not only public GitHub repositories, but the repositories of GitGuardian users. And the public repositories turned out to be just the tip of the iceberg. Thing is, private repositories are 4 times more likely to reveal at least one hard-coded secret when we compared them to the public repository. And this is for enterprise company. As you can see here, the Microsoft storage account keys, AWS keys, Salesforce or Okta tokens, most of the hard-coded secrets happen in the private repositories. And the reason we think this is happening is that private repositories give developers a false sense of secrecy or privacy. So our intuition is that it permeates this sense, causing even more leaks to happen and occur internally. And this reveals the magnitude of secret sprawl in organizations. Now, there are also more hard-coded secrets in these internal repositories than application security engineers can possibly handle today. So on average, what we saw that in 2021 is a typical company with 400 developers and 4 AppSec engineers. That's a usual ratio we see of 100 to 1. So such companies would discover 1,050 unique secrets leaked when they scan their Git repositories and the full commits. Now, each secret this is a unique secret, but each secret happens to show up in more than one area across VCS repositories, files, etc. So we also counted the number of occurrences, and each secret on average is found in 13 different places. So if we multiply the 1,050 unique secrets by 13 and then divide by the number of available AppSec engineers, we end up with this figure where one AppSec engineer needs to handle more than 3,400 occurrences on average. So this is far more than what can possibly be done by these teams. Now, when it comes to open source, GitHub is, of course, the first platform that comes to mind. Yet it's not only the only resource for code sharing. So since Docker popularized the use of containers to package software, its official public registry, Docker Hub, has also become one of the developers' favorites. So at GitGuardian, we said, let's take a look at Docker Hub images and see what's in there. Now, the layers making up Docker images are as many additional attack surfaces that can too easily be forgotten from the security perimeter. And for attackers, this is another chance of finding an access vector, just as we previously saw in the CodeCov breach. Now, Docker Hub is very big. In total, there's around 9 million publicly available Docker images. So we took a sample of 10,000 images and scanned it. And we scanned entirely each image from the creation process to all the layers, different file systems. And the findings were also interesting here. So we saw that out of the 10,000 images, there were 4,000 secrets and 1,200 unique secrets in there. So almost 5% of the images exposed at least one secret. And in total, for every 100 layers in the file system of Docker images, we found 6 secrets. So Docker scanning is also an important aspect that shouldn't be left out in security programs. Now, what can we do to curb the progress of secret sprawl? Let's go back and wrap things up. So why are secrets sprawling? First, because modern development practices require the use of secrets to connect the different components used in building software, right? And second, because source code is a very leaky asset. It is widely accessed, and moves through different places, developer local workstations, version control systems, the CI/CD tools they're using to test and release the applications, etc., etc. And also one other thing is that developers have to spend most of their time doing many different activities. So they will be ideating, planning, coding, testing, deploying the code. So all day long, they're moving up and down the software development lifecycle and going deep and wide on this SDLC. So this micro context switching makes the developers use a key for a test and then maybe forget it in the source code and say, okay, I'll come back to it, but never come back to it, and then push that code with the secret that's hard-coded in it. So that's one of the reasons why secrets end up in the Git repositories. Now, the threat, of course, is that after initial access to source code, any attackers will use it and try and gain some advantage and lateral movement. And it's a quite unsophisticated vector of attack, really. Anyone can just use the secret. So once attackers also have these credentials, it's very hard for us to detect that they are attackers because they are operating as a machine in a way. Now, the standards are today are catching up with the risks of hard-coded secrets. And for example, the NIST is including secrets detection in its recommended standards for vendor verification and testing of software. So this was produced under the executive order last year. So overall, the conclusion is that secrets must not be exposed in the software development lifecycle, and the risk of their exposure must be proactively handled during development. Now, one way we recommend doing this and to reduce the risks of exposure is to automate detection throughout the software development lifecycle. So on the one hand, you want to perform historical scanning to identify all VCS instances in your organization and scan the repository's full history. And on the other hand, you also want to perform continuous monitoring and continuously scan all incremental changes and all code that is incoming to the shared code base. And you also want to enable developers and DevOps engineers or SREs to integrate these real-time secret scanning into their workflows. So this will happen in the VCS, this will happen on local developer workstations, or in continuous integration environments. And we'll have a little demo at the end of how to use secret detection on local developer workstations. Now, there are lots of challenges with automated secrets detection. One of them is scanning the Git history. So scanning the latest version of the code is not enough to prevent secrets from being used. You have to take a look at all commits from all branches and make sure that none of them contain any valid secrets. Another challenge is dealing with the false positives. Some tools use either entropy statistics or regular expressions. We think that a combination of the two is needed for better precision, better accuracy here. And lastly, one of the main challenges is that detection is only half the job, really. Once you find the hard-coded secrets, they need to be remediated. These are vulnerabilities that cannot be just left there. And this requires streamlined collaboration between security and development teams who own the context. And sometimes remediation can be harder than expected and takes a lot more time and resources than we think it should. Now, let's take a look at the historical scanning and why historical scanning is very important for us. So hard-coded secrets, unlike other vulnerabilities that are found through static analysis of code, are not a runtime vulnerability. They do not manifest themselves in applications that are necessarily in production. They represent a threat by themselves, simply because they exist, simply because they're in the Git history, regardless of whether the code is running or not. And also one other challenge is that the Git history can be very complex, and sometimes you'll find that a secret has been removed in one, added in one commit and then removed in the next one. But if you are good with Git, you can still traverse all its paths and all the history to find the secret. And attackers with access to repositories will also do the same. They will be traversing all branches and all commits history to look for valid secrets. So it doesn't matter if it's on a feature branch, hotfix branch, or the main one, if it's from 5 years ago or from yesterday night. If it's valid, then it can be used against you. And once you have put in place your historical scanning for Git repositories, you also want to continuously scan incremental code changes at every stage of the software development lifecycle. And this can happen. There are many touch points where the secret scanning can be performed. So there are two different environments here. There are the remote environments that are shared across developers, and there are the local environment. There's the local environment, which is the developer's workstation or machine. So developers will be coding locally on their machine, staging changes, committing them before they push it to the central code base where the threat really lies. They can implement secrets detection in with pre-commit or pre-push Git hooks to make sure that the code that leaves their workstation does not contain any secrets. And on the server side, well, secrets detection needs to be implemented for the VCS at least, because that's the source of truth and that's where the ultimate threat lies. Attackers most of the time will gain access to that central repository, and that's where they will be looking for secrets. So if they end up in the repository in the shared code base, they need to be considered as a compromised secret, and incident response workflows need to be triggered. Now, they can also be ran in continuous integration pipelines, but it's also a bit too late because they've already entered the remote environment, the shared environment. But the reason why it can be implemented at this stage is that it raises the awareness for all the teams and for all developers, DevOps engineers that are running these tests, and the results of secret scanning there is displayed to everyone. So if there are any secrets, people will realize that, okay, we're doing a poor job here, correctly managing this secret, and we should rotate it, revoke it, and now find a better way to manage it in the future. The idea is to overall build a layered detection strategy that provides your engineering teams and DevOps engineering teams with a comprehensive security safety net. So at different stages of the SDLC. And lastly, if you are to implement a secrets detection program in your organization, we recommend you take it step by step. So it can be complicated. So we recommend a progressive approach to move forward to a zero secrets in code policy. First, we recommend that you start monitoring commits and merge or pull requests in real time for all your repos with VCS or continuous integrations. This is where the ultimate threat lies, and this is where keys will be extracted and exploited. And in the meantime, you can progressively educate developers to add scanning to their own workflows. So this can happen through pre-commit Git hooks. And this prevents the secrets from leaving their workstations and will save you lots of time down the line. And you should also educate them to manage secrets safely, however way that is done in your organization. So this can be by using centralized storage, .env package, or encrypting keys, etc., etc. So there are different ways. We'll not cover this here, but it's important to emphasize that developers need to be trained on secrets management. Third, you want to plan for a longer-term strategy where you will be handling incidents that are discovered during the Git historical scanning phase. And oftentimes, this reveals, as we saw in the state of secrets sprawl, thousands of secrets in the history. So the code base with 10 years of history will have 10,000 secrets, maybe 5,000 out of those will be valid keys. You want to tackle those one by one. Of course, it will take some time. It's a long-term strategy, a long-term plan, but you should go through them and you should have in place a proper vulnerability management program to remediate these incidents and make sure that they are completely mitigated. Lastly, you want to implement a secret security champions program to remediate all these high volume of incidents and tackle the different cases where the developers that committed the key, for example, is no longer in the organization. So they're not here, they cannot help you with that. That's something security champions maybe can take care of. And you also want those champions to promote the best practices in the organization and share their learnings with different teams and different members. So overall, we believe that this way you will be reducing, you'll be curbing the progress of secret sprawl within your organization and reducing, well, the amount of secrets that will reach the VCS. So these will be safe. And lastly, you'll be tackling all your past incidents. And once you will be done with those, hopefully you'll be spending much less time while taking care of secrets in code. Now, maybe we can take a quick look at how to implement secrets detection at the developer workstation level. So in a Git pre-commit hook. Should be here in a second. You can see my screen, right?
Yes.
Okay, super. So here I have a sample test repository that is basically a Node.js application in which I will be hard coding a secret locally, and we'll see how we can catch that before it reaches the VCS here. So in VS Code, what I did before this demo is simply install the pre-commit hook on my local machine. So I just ran these different commands, used the pip package manager to install pre-commit, and then created just a configuration file, pre-commit config YAML file, where I said I will be using ggShield, a command line interface, to scan for secrets locally. And we can find it here. So we're going to try and hard code the secret in one of our files here. Before we do that, let me just log in. This will just generate an API token that I will be able to use locally to scan for secrets. Okay, super. So now let me just take this database URL, and in my Node.js app here, I have a config file that connects to a database. So here I'm correctly using a environment sensitive variable to hide the database URL, and it should be in the .env. But let's suppose I want to test my connection to the database, see if my code is functional. And okay, I will take this back later. I will remove it. So once we have that, we save it. Let's do it. Now let's try committing. And as you can see here, this directly triggered a scanning on my local workstation. So what we can see is that the commit failed because the local pre-commit hook failed here. And the reason is, well, we found a secret. And this secret is, well, not completely displayed here, but this is the Postgres URL that I just put here. So this way, the secret did not even enter my Git history locally. So what I can simply do is remove it and then try committing again, and it should pass. But let's try maybe ignoring it. So now this secret has been added to my ignore list. Let's say maybe it's a false positive, or this is a test key that I do not necessarily care about, but I'll just hard code it in there. And now that it has been ignored, I will try committing again and then pushing my code. Okay, now that that was ignored, let's just push it. Now let's go to our GitHub page here and check what is going on. So what I also did was add secret detection to my CI, and I had a GitHub action running. And when I push the secret, this has triggered scanning here in the GitHub CI. As you can see in the CI, the check has failed because, again, ggShield, the command line interface, has caught the secret. And this is now displayed to all the teams that are using this GitHub repository. Now I also created a pull request.
We are losing the audio, Ziad.
Sorry. And GitGuardian found a secret in this pull request here. So again, it's the same secret, which is the Postgres URL credentials. And it can also display the guidelines for you to remediate hard-coded secrets, depending on the rules within your organization and who you should contact, how you should revoke it and rotate it, how you should redeploy your application, etc., etc. So these are the many different areas where you could implement secret scanning and where you should to raise awareness around the problem, to mitigate the threat of hard-coded secrets, and to have developers know that they should be not hard-coding those secrets in the Git repositories. And I think this takes us to the end of the presentation. So I don't know if there were any questions.
There were indeed. So okay. We had a few questions. Do not hesitate to enter them in Wova. So right now I have two questions.
Mm-hmm.
The first one is, do you provide or are there any open source tools to scan private repositories and container registries to identify exposed secrets? Could it work fully offline without exposing anything out of the organizational environment?
Yeah, that's a good question. So the ggShield command line interface, so we just saw here during the demo, is actually open source, but and uses a public API. But in fact, this public API is hosted on GitGuardian servers. Now, this means that people using this tool will be sending the code to the servers for scanning, and then it comes back with the results of the secrets in code or not. But it can also be deployed on premises. People can host the API in a way that nothing is exposed to the outside world, and the code stays within the organization's premises. And the same CLI you saw here can be used, well, to scan locally in developer workstations, but also in the CI pipelines, as we saw with the GitHub Actions workflow. And also it scans Docker images. So there's a dedicated Docker image scanning command.
Okay, thank you. Second question. We saw that one spike in the leakage of secrets on a Saturday in November, I think. Has there been anything special at that day that you could recall? Maybe you added a new detection, or was that day totally random and could have been any other day of the year?
Yeah, that's a great question. So what we try to do, of course, we have two different analyses. One that runs with the same perimeter versus the past year, and some that runs with a new perimeter in terms of secrets detectors, because the library we have keeps on growing, and we moved from 250 detectors to 350 over the year. So looking at the isoperimetric analysis, we did not find anything in particular on that day in November. Sometimes it's also not necessarily developers that are hard coding the secrets, but misconfigured developer tooling, misconfigured DevOps tooling that can be printing these secrets in the different areas we find them. So it's not always the developer here. But from what I know, it was a totally random event, but I will look into it and understand why the spike was there.
Thank you. I had another question. What makes our colleague secrets a different breed of security vulnerabilities when compared to other vulnerabilities found through, for example, static application security testing?
Yep. So compared to, let's take, for example, SQL injection vulnerability. It will only manifest itself for an application that is in production, and if the code in which that SQL injection vulnerability is deployed to the production app or not. So it depends on whether it's in the main branch, if it has been deployed or not. In the case of secrets, it's different. Even if it's something that's not deployed, if it's in your Git history, it can still be exploited. So if an AWS key is in there, it can still be extracted by an attacker, and then they will use it to spin up different EC2 instances and whatnot. So you have to take a look at all the hard-coded secrets, whether they're in a branch that's deployed in production or not. It's not just the last version of the code that counts here.
Thank you. Do not hesitate to post question. I have another one in my list. What are the biggest challenges awaiting organizations that are looking to tackle secret sprawl, and how can these organizations overcome such challenges?
So the challenges are multiple, really. One of the first challenges is realizing how much secret sprawl is a reality within the organization. So when organizations scan their Git history, all their repositories, all their VCSs, and sometimes these are in the hundreds or thousands of repositories, they will see that the results are will take them aback, because they will find thousands of hard-coded secrets. And one of the challenges is to plan for the remediation. So how are we going to tackle those secrets? What are the most important ones that we need to get started with first in terms of remediation workflows? How can we kick that off? How can we make sure that these will not be exploited? How can we make sure that we have all the context we need to remediate those secrets? Are the developers still in the organization, or have they left the organization? So it takes lots of planning before going dive into the historical incidents remediation. So that's one thing. But the other thing is also how can we prevent, that's the second challenge, is how can we prevent more secrets from happening? So from entering the VCS. And for that, there needs to be lots of efforts on the prevention side. And prevention can only happen with the help of developers, of course, because they're the ones who are writing the code and they're the ones who are checking the secrets into code, even if it's a mistake, it's not something they do on purpose. So for prevention, they need to equip developers with the right tooling, make sure that the CLIs they use, the local scanning tools they use will not be diminishing their productivity and blocking their development workflow. So that's one of the challenges. And make sure that it's adopted by everyone in the organization. So everyone needs to be using these tools to make sure that their secrets do not contain code, that their code does not contain secrets.
Thank you. Is there an overhead of using the solution in terms of workstation, for example? Or do you notice some overhead in terms of time between commits?
No, so most of the time, if this is implemented at the pre-commit Git hooks level, the scan will take half a second and it will just pass or fail. And if it fails in reality, the detected secrets will be very quickly removed by the developer. But even if it's 1 or 2 seconds, they are saving lots of time on remediation later, because when an application security engineer will send you a message to tell you, hey, we had received an alert and you hard-coded this secret, it will take you a couple of hours to revoke the key, rotate it, redeploy the applications, make sure that the secret is properly handled this time. So I think 1 second is acceptable in terms of delay.
Thank you.
Okay.
I don't see any more questions on the chat. The next talk is in 12 minutes, so you can take a small break if you want. Thank you, Ziad, for your time. So I will just turn off the video for the next minutes, and we'll start again at 11 sharp for the next talk by Maor Kurel from White Source on shipping product with confidence, or in the direct line of what you were presenting. Thank you very much for your time, and
I will be there.
Take a break, and we join at the next station. Thank you.
See you later. Bye-bye.
Bye-bye.